All right. Welcome to CIS256. This is our last lecture on Django framework. Today we can talk about data and model layers. And to talk about the model, we have to talk about some database stuff. And to talk about database, I think we need to talk about a query language called structured query language, or SQL. It is a programming language that allows to update and query a database. So what are databases? Well, you can think about a database is a software that can store data. And here we are talking about a relational database where we can find all the data stored in a number of tables, and there's relationship between them. So each of table is made up of a set of number of columns and flexible number of rows. So for example, here we have a table of a flight from origin to destination with duration. The simple table with 3 columns, origin, destination, and duration. So to store this table into a database, we can have several options. The popular one are MySQL, PostgreSQL, and SQLite. The first two are heavy-duty database that is used every day by industry, but SQLite is a lightweight database system that we can store data in a single file. And it's lightweight, and so we're going to use this as a demo example in Django. And it's a default system used by Django anyways. So columns are in the Excel sheet. It's like has a type in SQL, just like the programming languages, right? So there's a couple of typos in SQLite. Text, like strings of text, like name, location. Numeric, a more general form of number data, like a date or a Boolean value. Integer is a non-decimal number, like a person's age, and like a integer, right? Real number and a real number including a decimal, a person's weight, for example. And then blob is a binary large object. It's a binary data may not we want to store in the database, like for example, picture or audio form. So to create a table in SQLite, you can use the keywords create table in capitalized, and then the name of the table. In this case, we name it flights. And with parentheses, don't forget the semicolon at the end. Inside parentheses, we have column name, ID is type integer, and primary key. Each table will have one primary key, basically to uniquely identify the row, right? And we use ID as primary key. Auto increment is just saying every time you exit a record, the ID is automatically incremented by 1. And the origin destination in the table, these 2 columns are text-based. Not null, it just means that you have to fill some values, and duration as integer. So this is a example to create a table. So in other words, there's some constraint keywords in this syntax. Other than not null, you can primary key. There are several other constraints like check, make sure certain constraints are met before allowing a row to be added. Default provides a default value if no value is given. Not new, make sure value is provided. Primary key indicates the primary way of searching for a row in database. Unique means ensure no 2 rows have the same value in that column. Now, we have seen how to create a table. So basically, if you go to SQL in Replit, or you go to download SQL in your local PC, you can create a file that is basically a database, right? So basically, if you enter SQLite 3, sorry, let's create a new console. So if I do SQLite 3, if it's installed, flights, that's the name of the database. And then, oh, sorry. That's the shell, right? So in the shell, you can say SQLite 3 flights.sql. So create a new database, and we can create a new table. Basically, just like what we did here. So create table flights, ID, blah, and enter. Now you can see I create a table flights, right? And then we can insert some values into flights, okay? Origin, destination, and duration. These three values, and we give them New York, London, and duration 415 minutes. So if I do that, I insert a record into the flights, and then you can query the flights, right? So the query is called select. Select star means every column from the table, flights. And if you do that, you can see there is one record, ID is 1 from New York to London, duration is 415. So star will retrieve all the data from the flight table. Okay. We can also, if we only need certain subset of the columns, right? For example, oops, we only need origin and the destination from the table, and ignore the others. We can do this, so you can see, oh, New York and London. And we can also filter out some criterias. Let's insert a couple more entries so that we have more data to work with. So, oops. Let's insert Shanghai to Paris, 760 minutes. And let's insert another one. Let's say New York to Paris, and 435 minutes. Okay, and one more maybe. Let's say Moscow to Tokyo, well, to Paris, 245. Maybe one more. Lima to New York. Okay, 455. Maybe one more. Istanbul to Tokyo, and 700. Okay, so we get a bunch of things. So now let's select star from flights. Let's say where ID equal to 3. Yeah, number 3, New York to Paris, 435 minutes. That's the where clause, right? We can also filter by column. For example, we can do select star from flights where origin equal to New York. So all the flights that start from New York. So you can see there's 2 flights from New York. One is New York, London, and one's New York to Paris. Okay. So now that we know the basic SQL commands, let's test them out in the terminal, right? We already see this. And we can change setting to make sure the output more readable. So we can say mode columns. So we can see some columns here and headers, yes. So if with that, we can select star from flights. And you can see there is some columns. Let's make it more beautiful, right? So we can have some more selections, like all the flights that duration is greater than 500, right? So you can see Shanghai to Paris, Istanbul to Tokyo, or have more than 500 minutes of duration. We can use some logic and or in Python, just like in Python. For example, we can do select star from flights where duration is greater than 500 and destination is to Paris. Okay, so if we do that, you can see there's only one flight that meets the criteria. Okay. We can also use the word in. So we can do select star from flights where origin is from is in the keyword in a tuple New York and Lima. So if we do that, you can see all the selected flights are showing here, either origin from New York or Lima. You can also search in some regular expression. So you can do like from flights where origin is like percentage a percentage. So that's a graphical expression where the origin has a letter A in it. Istanbul, Lima, and Shanghai all meet that criteria. So this is that. We can also have some statistic function from SQL built into that, and it's very fast. So use those like average, count, minimum, maximum, and summation. Okay. So this is useful when you want to get some statistics from a table without reading the large amount of data. Okay. For example, we can do select count from flights where, let's say, duration greater than 500. And you can see that number of flights meet that criteria is 2. So some, statistics, you can do average, max, mean, and summation. Okay, so now we have seen how to add and search tables. We can also update the existing table. For example, if the duration from New York to London is no longer 415 anymore, you can do update flights, and set duration is 430, where origin is New York, and destination is London. So if you do that, you update the flights. You can also delete rows from database. For example, you can do delete from flights where destination is equal to Tokyo. So then, and then you can look at flights. And you can see Tokyo is deleted, and also New York, London is updated to 430 minutes instead. Okay, so that's create, insert, select, update, delete. And then there is some other additional clauses that can control the queries, like limit 1. So if you have multiple rows, you can limit the number of rows. You can order by some column and group by some specific column. And it can do halving, allows additional constraints based on number of results. Okay, so far we have only seen working with one table at a time, right? So, but many databases in practice are populated by a number of tables that relate to each other. So that's why the name relational database. In some way, in our flight example, let's imagine we also want to add an airport code to go with the city, right? So, for example, Chicago, Phoenix, Los Angeles is LAX, Phoenix PHX. The way our table is currently set up, we will have to add 2 more columns go with each row, right? With also repeating information multiple places at CTX associated with code Y. So one way we can solve this problem, deciding to have one table keeps track of the flights, and then another table keep track of airports. The second table might look something like like this. So ID code JFK is New York, PVG Shanghai, IST is Istanbul, LHR, London Heathrow, Moscow SDO, Lima is LRM, CDG is Paris, and RT is Tokyo. Now we have a table relating code and cities. Rather than sorting an entire city name in our flights table, it will save storage space. You're able to just have the ID of that airport. Therefore, we should rewrite the flights table accordingly. Since we're using the ID column of the airports table to populate original ID and destination ID, we can call these values a foreign key. So basically, you can separate the table into original ID, destination ID, and duration. And this ID, you can look into another table to identify them. These are called foreign keys. In addition to the flights and airports, airline might also have some data about passengers, like which flight each passenger will be on. Using the power of relational database, we can add another table, passengers with ID, first name, last name, and flight ID. And then you can look through those information by using the foreign key, flight ID. We can even do better than this. Some person may be on more than one flight. To account for, we can create a people's table that stores first and last name only, and a passenger table pairs people with flights. For example, this table, and then passengers only has person ID and flight ID. So you don't know the name of either of the passenger or the flight, but you can look at other table using those keys. So because in this case, single person can be on many flights, and a single flight can have many person, we call this relationship called many-to-many relationship. The passengers table connects the two is known as associated table. All right, so join query. So although our data is now more efficiently stored, it seems it's more harder to query some information now because you have multiple tables. Thankfully, SQL has a join query that can combine several tables together to add more information. For example, let's say we want to find the original destination and first name of every trip a passenger is taking. So you need a passengers table, you need flights table. We're going to use the unoptimized passengers table that includes flight ID, first name and last name for simplicity. So we only need two tables. The first part of the query looks very familiar. Select first name, origin, and destination from. However, there's no single table that can satisfy these columns, right? First name is in one table, passenger table. Origin destination is another table in flights table. So we want to join these two tables with the fact that the flight ID in the passengers table corresponds to the ID in the flights table. So we can do something like this. Select first origin destination from flights join passengers. So these two join together on passengers flight ID equal to flights ID. So that one foreign key equal to the other primary key. Using that, we can find out the information by joining these together. Now you have this view with first name and origin destination. And this join we call the inner join, which means we're ignoring rows that has no matches between the tables. There are other tables like left join, right join, and four other joins, which we won't discuss here in detail. Basically, left joins, right joins, while including some non-matches items from either the left table or right table, or both. That's fully auto joins, right? So that's the join statement. Indexing. Sometimes we can make a query faster if you have multiple millions of rows. If you index them, it will make things faster. For example, if we know that we often look up passengers by their last name, we could create index on last name and to ID using the command create index name, index on passenger's last name. Then when you query the passengers by last name, it will be very fast because it's already indexed. Let's next look at some vulnerabilities of SQL languages. So we know some basics of using SQL to work with data. It's important to see that the main vulnerability solution is called injection, SQL injection. What is SQL injection? Basically, a malicious user can enter the SQL codes as an input to some kind of program, right? Such that bypass the site security. For example, let's say we have a table store username and password, right? And then a login from the home side of the page. We can search for the user using a query like select star from users where username equal username and password equals password. A username Harry may go to site and type in Harry, username and 1235 the password. In which case the query looks like this. Take star from users where username equal to Harry and password equal to 1235. That's okay, right? However, hacker can type Harry quotation dash dash as a username and nothing as password. So it turns out that this is a valid SQL comment, and meaning the query what looks like this. If you take literally what the user types, -- and password. So basically, it will run this query and perfectly ignore the password. Because in the query, the password checking has been commented out, the hacker can log into every account without even knowing the password. And it's easy to solve the problem. We can use escape characters to make sure SQL treats the input the plain text, not as SQL code. And the abstraction layer on top of SQL, you can also use that to increase own escape sequence. So we don't have to write SQL queries ourselves. So Django uses the second method to make sure that whenever you have a input, you are escaping those things treated as a text data, not SQL languages. The other main vulnerability is race condition, where if you have a bank account, right, you have multiple queries to a database at the same time from different websites even. And if you not handle it correctly, it seems you may have a problem with the bank account. For example, let's say you have $150 in your bank. This condition could occur if I log into a bank account on both my phone and laptop, attempt to withdraw 100 on each device at the same time. The bank software developer is not careful enough with risk conditions. You may want to be able to draw 200 from an account with only 150 in it. The bank is broken, right? So what potential solution for this is to have a lock mechanism in the database. A lock is basically some way to tell others this database in use, do not do anything until I'm done. So the lock allows one transaction only at the moment. Until it's completed, no other transaction can occur. In the bank example, after checking, clicking navigation to make a withdrawal page on your computer, the bank may not allow you to navigate to that same page on your phone. So that's the risk condition. Okay, so I think that's all for the SQL introduction. And we'll talk about the Django models in the next lecture. Bye.